So this is a demonstration I usually like to do in class just to show you what would happen if you actually went to visit Venus because the pressure is so high. The pressure again is 92 bars, which is a lot. So I like to do this. What I do is I just put a little bit of water in the bottom of this can here, and you just heat the can up. And what it does, it'll make the water inside boil, and the pressure inside the can from that water boiling, it pushes on the side of the can, making the pressure a lot. And then I'm just going to put the can in ice water, which is going to suck all the heat out very, very quickly. And when it sucks the heat out, it means that there is a pressure difference. There's going to be more pressure outside the can than inside. So watch what happens. So it just collapses in on itself very quickly. You can just see it and hear it go very quickly. And that's what would actually happen to your body if you went and visited Venus. The pressure inside your body is so much less than the pressure outside. So it would completely just collapse your bones, all your vital organs, just everything. Your entire body would just cave in. Okay, so this is where we left off. I just showed you what would happen if you went and tried visiting Venus. And we talked about the surface pressure being 92 bars. And so as you're falling towards the planet, that demonstration just showed you that's what would happen to your body as you're going through. Your body's also going to be eaten by the sulfuric acid, and it's just not going to be very, very, very good for you at all. That's why we don't have very many probes that have actually been. The United States, with NASA, has never actually had a probe land on Venus. They're currently trying to figure out how to make one that will last. The only country that's ever sent them to the planet to land and actually have is Russia. So the Russians sent probes called the Venera probes. There were several of them that went. The Venera 14, I'll show you some images of the surface from the Venera 14 in just a few minutes. That's the one that lasted the longest with about 57 minutes. That's how long it lasted. And the reason they're called Veneras is because Venera actually means Venus in Russian. So this is where we left off, so we're going to keep going from here. So the reason that pressure is so much, the reason there's so hot on Venus is because of the runaway greenhouse effect, which basically means that the energy that is makes its way from the sun to Venus, most of it gets absorbed by the planet. Not very much of it gets escaped because of all that carbon dioxide gas, which is a greenhouse gas. So visible light passes through the atmosphere. That light hits Venus, becomes infrared. Infrared cannot escape through the atmosphere, so most of it ends up getting absorbed, which is why it's just so hot. And we talked about this already, but we said Venus is mostly carbon dioxide. 96.5% carbon dioxide of the atmosphere is in the atmosphere. It's too hot for the carbon dioxide to bond with the rocks. On Earth, most of the carbon dioxide is in the surface rocks. Most of the water vapor is in the oceans. And there isn't really much water vapor at all on Venus. So that's why there's all those clouds of sulfuric acid, and there's just such a haze, and you can't see the surface at all because of that carbon dioxide gas. So views from the surface, most of the views we have are from radar mapping. So the United States, NASA has sent a couple probes that have actually given us radar maps. The best one we had was in the 90s. It was called the Magellan probe. And I'm going to go over all the probes and satellites that have actually gone to orbit around Venus in just a second here. So this is actually a true image of the surface of Venus. So you can see it looks very dry and cracked rocks right here. And this right here, this is actually the lens cap of the camera. It actually fell off of the Venera. Again, it only lasted 57 minutes. So as these probes are making their way down to land, they're actually being crushed. The metal is being corroded away from the acid, and they do not last long at all. So this was only a few of the pictures. These are very few of the pictures that we have. You don't get to see much of the surface at all. With the images we do have using radar maps, this is what we see. So most of Venus, this blue area here, most of Venus is actually flat. Between 70 and 80% of Venus is actually flatlands. And then you've got two, they're called terras, but they're highland regions. So highland regions on Venus are called terras. Make sure you know that. There are two terras. This is called the Aphrodite Terra, and this is called the Ishtar Terra. So those are the highlands of Venus, with the rest of Venus being flat. So there are mountains and there are lots of volcanoes on Venus, which means there's lots of lava because it is active. This region in red, this is called Maxwell Montes. This is the highest mountain on Venus. And then the highest volcano is actually called Mont Mons. So I'll show you that in a second. These names, Aphrodite, again, that's the Greek name for Venus, which is the Roman for the goddess of love. And then the Babylonian and Assyrian name for the goddess of love is Ishtar. So that's where those names come from. So Ishtar Terra, Aphrodite Terra, just other names for Venus, basically. This is just how radar works. So what we do is we send radio waves from the satellite spacecraft orbiting around Venus, and those radio waves will bounce off the planet and return. And based upon how long it takes for those radio waves to return, we know how high an object is off of the surface of Venus. So we can tell how high and low the surface of Venus is by those radio impulses striking and coming back. So let me go ahead and move through that because that just tells you how this works. So these are some of the surface features of Venus. There are lots and lots of volcanoes. Those volcanoes on Venus, not too many of them get very high. That's why they actually look like pancakes. Another name for these volcanoes they're called pancake volcanoes or lava domes. And what happens is the volcanoes, they can't get very high because of all that pressure. So you just have a bunch of lava at the surface of the planet. And it wants to just explode, but the pressure makes it really, really hard to. And so you have these big mounds of lava that look like pancakes. So the lava is very thick and it doesn't run very well because of that pressure and heat on the surface, keeping it together like that. This is the largest volcano. It's called Mont Mons. And then you got a bunch of fractured plains, a bunch of cracks, just dry land from not having any water vapor. And then there's also quite a few craters. So two of the craters, I do want you to know these. They're called the Mona Lisa crater and the Meade crater. So the Meade crater is the largest crater on Venus. I'll talk about that in a minute. U.S. exploration of Venus, you need to know these probes, which probes went where, so you need to know these. So Mariner 2 and 5, they went by in 1962, 1967, and they did what are called flybys. So they fly by, they don't actually orbit around the planet, they just fly by, take some pictures, take some measurements, and then move on to another planet. Mariner 2 did a flyby in 1974. Pioneer Venus was the first probe to give us radar mapping, very low resolution radar map because it was in the 70s, 1978. And then the last probe we sent was called the Magellan probe. That was sent in 1990, and that gave us high resolution maps, which was like the one I just showed you. That showed us most of Venus is flat, with 80% being flat, and the Ishtar and Aphrodite Terras, just like this. So this is what the Magellan probe gave us. Okay, so terrain, we need to know these. So Ishtar Terra and Aphrodite Terra, those are the two highlands. The higher one being the Ishtar Terra. The Meade crater, we need to know that's the largest crater on Venus. And the Mona Lisa crater, that's also a very large crater on Venus. And the way I remember them, so Meade crater, that's actually named after an anthropologist here on the Earth. Her name was Margaret Mead. And then I remember those names because I call Venus the planet of babes, basically. So you got Venus, who's the goddess of love. Ishtar, another name for Venus, who's the goddess of love. Aphrodite is the goddess of love. And then you have Margaret Mead and Mona Lisa. I mean, they're both babes, right? So that's how I remember them. It's just, you got craters, they're going to be named after babes. This just shows you the fractured plains. And this is actually from a probe on its way down, one of the Venera probes that was coming down to land. Just see a bunch of fractured plains, maybe some lava flows. So we said 80% is flat, very similar to the ocean floor, made of basaltic rock. Two uplift plateaus, the Aphrodite Ishtar Terra. We said you have lava domes or shield volcanoes, which look like pancakes. You've got craters like Meade crater and Mona Lisa crater. No tectonic activity. So there are those pancake volcanoes. Sif Mons is another large volcano. We said this is a radar map of Venus, infrared map of Venus, showing you the temperature of Venus. Last thing before we're done here, magnetic field. So we learned that there are two conditions needed for a magnetic field. You need a metal core and fast rotation. So we know Venus is a sister planet, so it does have a metal core, but does it have fast rotation? You guys remember what the rotation of Venus is? So it takes over 200 days for it to rotate once. So it does not have a fast rotation. Therefore, there is not going to be any magnetic field. So no detectable magnetic field, very, very slow rotation. So definitely no magnetic field. So remember, on a test, we need to know that it rotates 243 days. That's how long it takes for it to rotate once, going backwards. So that is going to be it for Venus. I am going to post the chart for Venus, so make sure you take a look at that and get your information, because again, you need to know this stuff for your test, guys. So please look at the chart and review these notes. And I miss you guys, and hopefully I'll get to see you soon.